Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com.
Welcome, everyone, to our Everything Building Envelope podcast. I'm Chris Matthews, VP and Principal Consultant for GCI Consultants, and I'll be your host today. I'm excited today to have as my guest David Hansen, one of our GCI consultants and project managers that I've worked with here at GCI for a number of years. And David and I have known each other a lot longer and worked with each other many years in the past. We've got an interesting topic today, and David's going to talk to you about some of the things he's learned in his 30 years in the industry, problems and recommendations he can offer to you. So David, since this is your first time as a podcast guest, please tell our audience a little bit about yourself, and then we'll jump right into our topics.
Hello. Once again, my name is David Hansen, and I've been in the glazing industry for approximately 30 years. I started in the mid-'80s as basically coming in and fabricating, cutting the aluminum stock lengths for curtain wall, window walls, actually screwing the panels together, building the framework. And that's where I also learned about structural glazing, because most of the systems that we did were actually structurally pumped with sealant. So that's where I started. And from there, we did curtain walls, storefronts, window walls. So I actually began at the ground level, fabricating, installing, building all these frames and units in the shop, and then going out and installing them in the field. From there, I also had the opportunity to work with a lot of really good mechanics doing custom glass work, such as mirrors, glass enclosures for very wealthy people, their showers, bathrooms, anything you could think of, custom anything. And that's really where I got my start. And then from there, I was promoted and I became a project manager, actually ordering and overseeing entire projects as far as curtain wall, window wall, anything you could think of with glass and glazing. But the company I was with, they were predominantly in curtain wall, and that was their forte. From there, years later, I actually did get into designing systems along with our structural engineer, being that our structural engineer was very good with making a structurally sound system but had little experience in the field. That was where I came in, because he would come up with a design for a system, and I kind of poo-pooed it because I said, no, this is going to be too hard to install. It's tough. I mean, you can't do that. So we definitely went back and forth and designed quite a few systems. A lot of them were completely custom systems, curtain wall systems for buildings. Some were even already standing. The customers, I remember one job in particular, the customer had a need where they wanted to redo their whole building, a 15-story building, but they wanted to leave everything they had intact. They wanted to be removed from the interior, and they wanted to completely clad from the exterior, which we did. We designed a complete system that's curtain wall system that went on the exterior of the building, and after it was all finished, we removed the windows that were 50 plus years old from the inside, and then designed applique on the interior to finish it off. And from there, I went on to actually going into sales, and then oversight of an entire department, a wing of the company that I was with. So I guess you could say I've pretty much done it all with glass and glazing from the ground up. In my first day, I remember pushing a broom. I mean, so yes, I've pretty much done it all. Anything you could really think of.
And that's we've got a mix of people at GCI with different types of experience, but we've got some people like David that have done it all and seen it all from the ground up, like he described. And then we've got some engineers and architects that their background started from the formal education standpoint. So it's a great mix of people that we have here, but you can't substitute for that experience of being out there, having your hands on it, knowing how it's put together, knowing how it's installed. That knowledge, you have to see it and experience it to be able to pass that on to our clients. And so you talked some, David, about both of the main parts of a glazing system, the aluminum framing components and the glass itself. What's some of the biggest problems you see with safety glazing, the glass itself, and some of the stuff you've worked with?
Well, with safety glazing, particularly say tempered glass, I know a lot of architects will instantly they'll put tempered glass on the exterior of the building, and that's something you want to hold back and not do. You only want to do tempered glass where it's required by code, because there's inherent flaws with tempered glass, such as the big elephant in the room always is nickel sulfide. You don't see too much of it, but that possibility can exist, and it only exists with tempered glazing. It's a little inclusion, a little flaw, a contaminant in the tempered glass that's microscopic. You can't see it, but if it is there, that piece of tempered glass can be a ticking time bomb. It can blow down the road. And the only way you can really detect that really helps with that issue is heat soaking. It's not a foolproof system, but it does help, but it is costly. So, I mean, whether you decide to do that or not, it's really what your budget would allow. But that's really exterior glass. As far as tempering, another problem with exterior tempering, usually the roll distortion, the tempering roll distortion of tempered glass is usually more predominant than heat strengthened. And you also want to make sure that your roll distortion is parallel with your horizontal dimension, meaning that when you're driving by the building, the glass, the tempering wave distortion flows with you. It doesn't look like you're in a carnival, which means your roll distortion is horizontal. If you have it going the opposite way, that roll distortion is vertical. And then when you drive it by the building, it'll look like it'll look like a carnival. It looks bad. But the other thing, aside from exterior glazing, that you want to be careful of, that I have been called out quite a few times here, is say I have had architects where they've designed elegant bathrooms and they have tempered glass in their showers and bath enclosures. And I know architects, they're going for the beauty. They want to have a beautiful installation, which means they'd like to have that glass all the way up against their perimeter substrate, whether it's marble or drywall or whatever it may be. You've got to be careful and you got to have the right gap there between. I know a lot of people, they don't like the look of silicone between the glass and say their marble countertop, but you've got to have it there, because when you have expansion and contraction in the glass or in your perimeter substrate, that can actually put too much tension on the glass and it can actually blow a piece of glass. Another big problem with tempered glass in these same type bath enclosures that people don't know about is they look at the piece of tempered glass and usually they have like flat polished edges on the glass, but you've got to be very careful that none of these flat polished edges, you'll see a chip at the corner or the edge of the piece of glass, and that's a ticking time bomb, because you don't know whether that chip happened before or after tempering. If it happened after tempering and it didn't blow the piece of glass into 1,000 little pieces, it can at any time explode. And that's something you really need to be careful of. You've got to inspect that piece of glass and make sure that when that's installed in your bathroom enclosure, there is no damage to any surface, any of the corner areas especially, or along the polished edges, because that can have your glass can blow at any time. It's a ticking time bomb. And that's pretty much it that I see for interior glass. You just got to be careful that you have no flaws in that piece of glass.
Well, and you covered a lot of ground there, and I think that the big takeaway from that is that there are appropriate types of glass for different situations. Like you described, on the exterior of a building, tempered glass is stronger than heat strengthened or annealed glass, but there may be situations where it's not the best option. And then, as you talked about in the bathroom, it's not just having the right type of glass, but having it installed in a safe manner so it's not going to cause problems later on. And I know recently, like you said, we've had quite a few projects that you've been involved with where these fancy bathroom enclosures, shower enclosures have some problems because they've got the right type of glass, but maybe not the expertise to get it designed and installed in a safe way, which is a way that we can help people.
You're exactly right with that, Chris. You're exactly right. Another issue that I have noticed is if you have an elegant bathroom enclosure, say a rolling door, they purchase a kit from a manufacturer and they install it. And if you don't have good installers where they really know what they're doing, they may not adjust that hardware properly, and you've got to be careful. I just recently came from a job where they installed it, but they didn't have all the glass stops set properly. So this glass, this half-inch tempered glass, was actually hitting the wall. And you know as well as I do, when you bang into any kind of hard surface with the edge of a piece of tempered glass, it's going to blow. It's just a matter of time. So you've got to really be careful and install it properly.
Right. And the tempered glass is obviously much safer than non-heat treated glass. And that's why the codes require it in these dangerous locations. But people can still be hurt. And,
definitely.
And you want to not only have the right product, but have a good design overall, good functional design where you're not going to have problems. And that's kind of what we do at GCI in general is people usually have pretty good products selected, but we help them get it put in the right way so it's going to function, so it's going to do the job that they hoped it would do, but they might not have the knowledge sometimes to make that happen. So kind of moving on over into the glazing systems themselves, when you get involved with a new project, what are some of your first steps in reviewing the system, getting familiar with it, helping our customers to get their glazing systems installed and functioning right?
Well, the first thing I like to do is pull up all the documents on the system, actually pull up the glazing system shop drawings to see what they drew, and then pull up the product approval for that system to see structurally what it makes, the tolerances that are built into the system, meaning what is that caulk joint. Say, like if it's a structural glaze system, a lot of times they're built in, say, where you're able to have as much as a 1/2 inch or 5/8 caulk joint. Anything more than that may not be approved. If it is larger than that, a lot of times you'll need larger anchors, longer anchors, more of them. You've just got to really look at all of your information before you go out and look at a glazing system. Because unlike like an aluminum system or a louver, that's one item. That's one item that goes into that clad system. With the glazing system, it's like, I guess you could compare it to like buying a boat. Yes, you're buying this glazing system, but there may be 50 different itemized products that go into that system, and you want to make sure that they're installing that exactly as it's supposed to be installed per the engineering and per the product NOA. Because I have witnessed recently where the shop drawings and the NOA say one thing, but you go out to the field and you see what they're doing, and they will sometimes substitute materials for that glazing system. And that's not right, because that can lead to problems down the road.
Sure, and we see that on the litigation end of what we do quite often, in that what was shown in the drawings on a project might not be, on a quick look, it looks like what's shown in the drawings, but when you start digging in, there's parts and pieces that have been substituted, the wrong thing used, and then you've got performance issues down the road because, like you said, with a boat or a car or anything else, it's designed to operate properly with these exact parts. And when you start substituting things, maybe not even to save money, just because this was on hand and this wasn't or whatever, people are rushed during construction, trying to get it done quickly. You know, things get overlooked or put in there that shouldn't be. And then we end up seeing it later on that, you know, those kind of things result in a lot of problems for people.
Oh, sure. Yeah, you see that all the time. You see it all the time where there's products, pieces, parts that get substituted. And also a big thing is when, say, like a gasket is supposed to be installed a certain way and it doesn't, it's backwards. I mean, there's always installer error. You see it all the time. It's just, they're people installing these systems, and you need systems that are very user friendly, where somebody can come to work and he's in a bad mood or in a hurry to get home. It doesn't take a huge amount of knowledge to install a simple system the right way. But if you have a labor intensive system, you've really got to be careful. You've got to have top-notch installers along with supervision for these installers. And if you don't have it, mistakes are made. It happens all the time.
Sure. So I think I know your answer to this one, but what's your opinion on wood bucks and glazing systems, wood bucks at the perimeters of window openings, how those get sealed properly, integrated with the system, everything related to that?
That's a really good question. I'm glad you thought of that. I remember 30 years ago, 20 years ago, installing systems where I thought it was a great idea to install, a lot of times you have a square perimeter opening with cast in place concrete or even block, to put polyurethane, Vulcum, with wood bucks right up against the perimeter of the opening and install your glazing system into that. I've heard it so many times when I see details like this where GCI does not recommend wood bucking or any organic materials at the opening. But I remember 20, 30 years ago, this is common. It was very common in the field to just take a pressure treated wood buck, polyurethane sealant right to the perimeter of the opening, nail it in, and then install your glazing system. And I thought that was okay. But then when I came to GCI and I did see that it was not part of our recommendations, and we recommended a fluid applied waterproofing at the perimeter, I thought, wow, do you really need that? I mean, I don't know. I know that it's been done this way for so long. What do you really need? And then I remember when I first started at GCI doing a few water tests with our testing techs and actually seeing a system that was installed without waterproofing at the perimeter. And yes, that glazing system, whether it's a single square frame in a cast in place or block opening, you think, okay, it's sealed in, you're good. No, but you're not good. I mean, it was kind of a big eye opener for me when I actually saw the concrete leaking. It was pulling water in. The glazing system itself worked fine, but the concrete was leaking water. It was actually flooding to the inside. So, I mean, unless you have that weather barrier on the exterior, the water will come in. I mean, I was amazed when I saw that. I really was. So that was a good eye opener for me here at GCI. So now we recommend a fluid applied waterproofing at the exterior of the opening, the whole perimeter opening, and extending onto the vertical face approximately an inch or two, depending upon what type of cladding system's out there. That will keep the water out of the system. So it's very important, which was a big eye opener.
Sure. Yeah. And, you've got a tested product. If we're talking about a window that comes from the factory, fully manufactured, you've got a tested product that most likely is going to perform well. But then, as you say, if you install it and seal it to something around it that's not going to keep the water out, it doesn't really matter how good that window is. And, I've had that same experience as you. Once you see that water test done with that negative pressure on the inside, pulling that water in right around that window through those wood bucks, you understand right away that, something better has got to be done. And this old, they call it like the Florida flange. We see it still a lot in South Florida with the wood block wall with direct applied stucco, wood bucks around it, and then that Florida flange back bedded up against those bucks. And if you don't have those bucks waterproofed, you're going to have a problem. And it's just one of those things that who knows how it ever even started. Just like you said, they've been doing it that way for probably longer than you and I have been doing this. 50 years they've probably been doing that or more. But nobody can remember who was the genius who thought this was a great idea in the beginning.
Yeah, I know. I mean, I've heard it so many times. It's actually kind of funny. It's like, I've been doing it this way 30 years, and I'm sitting there thinking, well, you know what? Up until probably about 5-6 years ago, I might have kind of agreed with you. But now that I see what a water test and whenever water is pulled through that building just to see what it does, it's not the right way to do it. It's definitely not. I've even had guys come up to me and say, you know what, I sealed those wood bucks to the block with Vulcum, and I also ran an exterior polyurethane bead, and that's how we ran our stucco right up to the face of those bucks, and that's the way I've been doing it 30 years, and by cracky, that's the best way to do it. And I remember, well, you know what, yeah, I thought that too, but it's not. It's definitely not.
Well, and even though some of us here at GCI are old guys, we try to keep learning, right? You don't just say, okay, well, we've been doing it this way for 30 years and, there's nothing new out there. There's no better way. We try we try not to make our clients a guinea pig either. So it's a little bit of a balancing act. There's new stuff, new products, new ideas all the time. We try to give them things that are proven, that we've got experience with and we know will work. But we also try to take advantage of advancements, right? You don't just, we're not still living in caves either. So you try to balance that out as far as the way we've always done things with, there might be some better ways to do it too.
Yeah.
So, well, and you touched some on the sealants. You were talking about the polyurethane sealants that are installed around those wood bucks, but kind of talk to us some about the different types of sealants that you see used and what you recommend for different applications and why people can't just go down to the Home Depot or the hardware store and buy whatever they see in a tube there.
Well, I have seen people go down to the local hardware store and use that. And then 2 weeks later, you wonder why it's pulling away from your aluminum framing. I mean, there's a reason why that these sealants are a little more expensive. You have manufacturer support. And you've got that proven track record that we were just speaking of. I mean, they're always trying to improve their sealants. I mean, so basically, the biggest sealant differences that I see or being used out in the field are polyurethane and silicones. And polyurethanes are good for their chosen application. Whenever the sun, if you have any application where the sun's not going to kill it, because polyurethane will degrade pretty quick in the sun. Now, I know there's a lot of installers where building owners, they don't want to fork out the money because silicones are a little more expensive. They don't want to fork out the money with the silicone at the exterior of their glazing system, so they'll want to use a polyurethane. Well, I always say, yes, you can use the polyurethane, but if it's going to be exposed to the sun, you realize that you're only going to get a few years use out of this sealant. I mean, it is better if you say paint the polyurethane, which that's another good application of the polyurethane. You can paint it, and the paint will stick to it, and you will get probably a few more years out of that. But most polyurethane manufacturers, at best, you're ever going to see is a 5-year warranty. With silicone, if you actually have a good, properly formed silicone sealant joint in the field, you can get a 20-year warranty. You can get a 20-year warranty, which is great. I mean, there's a big, huge difference between silicones and polyurethane. Like I said, 30 years ago when I was installing glazing systems using silicones, that's mainly all that we used with the exterior storefronts, curtain walls. I've gone back 30 years later. Even though the manufacturer would provide a 20-year warranty, I've gone back 30 years after installing this building, and you look at the sealants and you start poking at the silicone bead, it looks like it was just installed yesterday. It's amazing. I mean, the ultraviolet does not bother the silicone. It's amazing what I've seen. But the polyurethane, on the other hand, it will degrade with the sun. But once again, if it's the right application where it's not in the sun or it's in a wet condition, the polyurethane is better, where you've got to keep most all silicones out of any kind of standing water because it will degrade it within a very short time. So basically, the bottom line is, yes, there's a cost difference between the polyurethane and silicone, but I mean, as far as a maintenance down the road, silicone, you can put it on, and if it's put down properly, your substrates are tested before they're put down, so you know exactly what cleaners to use, what primers to use. Once they're installed in their proper hourglass shape, they'll be there forever. They'll just last. I mean, I've seen them 30 years and they look still brand new. A silicone it's a beautiful thing. But once again, it depends upon your installation. It depends upon where you're installing these materials.
And like the glass we talked about in the beginning, an appropriate product for the application that you have. We're big believers in silicone anywhere that it's exposed to the UV. And what we try to explain to our clients is, kind of looking at it with a little longer range view, in that the polyurethanes may be a little less expensive up front, but how much are you really saving if you're going to own this building for any extended period of time? The silicone could still be there 30 years from now, and you might have had to replace that polyurethane sealant 5 or 6 times in that 30 years. So,
I've seen it going out to the job site where polyurethanes were put down, and say 6-7 years later, where they're starting to crack up and pull away. Actually, building maintenance people will go out there, and they'll go to the local store and buy whatever they can on the shelf and just go out there and just start adding to it. You always see that, where they're just dabbing more sealant into the opening. It's a maintenance deal. It's a maintenance problem, and it depends upon how long you want to have a maintenance-free building.
Exactly. Right. Well, you can see from our conversation today that David's got a lot of knowledge about a lot of products and systems, especially exterior glazing systems, and how they are intended to function and how to keep them functioning right, get them installed in the beginning so they function right. And we would always be willing to talk to you about any projects and concerns that you may have. And he's a great resource, and I thank him for joining us on our podcast today. And thank you to our audience for listening. We invite you to take a further look at our GCI Consultant Services on our website at www.gciconsultants.com. And you can also reach out to us at 877-740-9990 to discuss any of your building envelope needs. Thank you again, and I look forward to talking with you the next time on our Everything Building Envelope podcast.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.